Looking at number 9, in 2019, the distribution of the golfer Lexi Thompson's driving distance at a mean of 276. Assuming her distribution of driving is approximately normal. Remember, that's a key thing we phrased yesterday. Is approximately normal means I can do a normal curve with an 80th percentile of 290 yards. Calculate the standard deviation. So they tell me mu. They tell me a percentile. And they tell me that the number that represents that percentile, that's my x, is 290. All right. So as we were working yesterday, we had our z-score is equal to x minus mu over standard deviation. So first thing we had to do was convert the 80th percentile to a z-score. So this is where we would say, okay, 80th percentile, that's 0.8000. I need to go to the chart. So back over to green, up into that page. There we go. Find 0.800 in the center somewhere. Boom, 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 boom. There we go. Somewhere in between that zone right there. It looks like if I'm just looking at 0.8000, it is 5/10,000ths off of that one, whereas on this one it's 23/10,000. So technically we're closer to that column. So that would tell me I have 0.8, and then it's in the fourth column. So my z-score is 0.84. So we'll go back over into our little notes. And we know our z-score is 0.84. That's equal to, my x is 290. I know the mean is 276. And then I'm trying to find the standard deviation. So we can go ahead and subtract what's on top. So we can go ahead and say 0.84 is equal to, what is that, 14? 14 over the standard deviation. And then now I'm going to multiply both sides by standard deviation. And that gives me that 0.84 times the standard deviation is equal to 14. And then I divide both sides by 0.84. So now I get to hit the calculator and do 14 divided by 0.84 to figure out what is the standard deviation. And I get a standard deviation of 16.66 repeating. So I'm just going to take it out to 4 decimals and say there's my standard deviation, 16.6667. Now, eventually what we want to try to do, or to speed things up when we're doing it by hand, if we are trying to solve for the standard deviation, we should realize at some stage that the standard deviation and the z-score just traded places through the inverse operations. You know, we went through it the long way and showed that, hey, you know, multiply both sides by standard deviation, then divide by the 0.84 as we did all this other junk. We should realize that, hey, in the future, if I'm solving for standard deviation, let me just put that where the 84 is and bring the 0.84 down below. And then I can do it a lot faster. I can skip a couple steps. All right. Now, number 10. And this is a similar problem. They're asking us to calculate the standard deviation. So right now, we're not ready for that new feature I want to teach in the calculator. Eventually, it should pop up. If it doesn't, I got some things ready to put in there for us to go through. So according to a 2019 study, remember, you can always work faster than me. People spend an average of 1.25, there's my mean, 1.25 minutes on their smartphone every time they pick it up. I would say that is probably low for this class of an amount. I would think our class would have a higher average amount of time when they pick up their phone on there. If Noel's distribution of a smartphone use is approximately normal with a mean of 1.25 minutes and a standard and a 97th percentile, 2 minutes represents that number. what is the standard deviation? Okay, so we know the x is 2. The mean is 1.25. So I need to take my 97th percentile and make it a z-score. So 0.9700, what does that become as a z-score? So I'm going to go back to the chart and find 0.9700 inside. 0.97, somewhere down here. Somewhere between the 8 and 9 columns. 0.9700. So I think it's closer to the 8 column because it's only off by 1/10,000th. It's a lot closer there. It's off by 6/10,000ths. Either one we're fine with using. I'm going to use the 8th column. So that gives me a 1.88 for a z-score. Come back over. And 1.88. And then we say, all right, 1.88 equals 1.2. Whoops, sorry. Off a little bit there. 2 minus 1.25 over standard deviation. So 1.88 is equal to 0.75 over standard deviation. As I mentioned in the previous problem, those things just basically trade places instead of doing a whole lot of inverse operations. So standard deviation is equal to 0.75 over 1.88. So now I'm ready to go to the calculator. 0.75 divided by 1.88, and I get a standard deviation of 0.3989 approximately. And I would say, don't be surprised if, I like on this one I did the little 2 squigglies to indicate approximate. That's what that one is. Since we are rounding, it is technically an approximation. It's not an exact because the decimal never stopped. We decided to round it. So when we look at pickiness of things, number 11, the sub shop, they're asking us to find the mean. Actually, the next 2 problems are asking us to find the mean. So we should be able to do those pretty quickly as we go through those. And then eventually, I think finally on 13, we'll be able to get to where I want to use the calculator feature on 13B. So let's knock this one out. 20th percent of these sandwiches are shorter than what length? So 0.2000. My standard deviation is 0.2. My mean, we got to find, and we know that the x is 11.7. All right, bless you. So what's the z-score associated with that amount? Should our z-score be positive or negative? Negative, why? Below 50%, thank you. It's below 50%, so it should be negative. Boom, boom, boom. There we go. I think I found the thing. There we go. Somewhere here. 0.20000. We are off on this one by 0.00045. Over here, we are 0.00. Was it? What'd you say? Yeah, thank you. 234. Thank you. So we are technically closer to the left-hand column. It seems like all the ones we've been doing with the way this book has their thing, taking out 5 decimals, we're always seem to be going down to the one on the left is what I noticed yesterday and today so far. So we are in the 4th column. So negative 0.84 is our z-score. So negative 0.84 is equal to 11.7 minus my mean divided by my standard deviation of 0.2. Now, does it make sense? Should we have a negative z-score? Yeah, because you guys told me we had less than 20%. Also, this also indicates that my mean should be what when we get done, comparative to that 11.7. Gee, it should be higher, it should be bigger. Okay, it should technically, my mean should be bigger. If I'm getting a negative z-score, then I should have a mean that's bigger than 11.7. So here we can just go ahead and multiply both sides by 0.2. And then get our little handy dandy calculator here, negative 0.84 times 0.2. And we get negative 0.168 equals 11.7 minus mu. Now, technically, I'm going to speed things up. Really, I'm going to trade places with the mu and the negative 1.68. Since they're both negative, they both get added to the opposite side. So I'm just going to trade their places and say that mu is equal to 11.7 plus 0.168. There's other ways you can do it, but we should get a mu of 11.868 is what we should get for a mean. Again, you could have subtracted the 11.7. You would have had negative 11.868 equal to negative mu. Divide both sides by negative 1, and you get the positive 11.868 that I have there. All right, let's skip down to number 13. We'll do 13A, and then with 13B, I get to show you the calculator method. So, IQ test scores, the Wechsler Adult Intelligence Scale for a 20 to 34-year-old age group are approximately normally distributed with a mean of 110, a standard deviation of 25. What percent of people aged 20 to 34 have IQs between 125 and 150? So now on this one, do we have to use the z-score formula to figure this out? No. What can we technically use? Yeah, we can use normal CDF. Okay, so we throw in a little change here. They were saying they're approximately normal. They're not asking me or giving me a percentile on this part of the problem. So I don't need a z-score. I mean, I could convert the z-scores and use a z-table. I just think it's a lot easier. As you guys said, we can use a normal CDF on this one. So let's go normal CDF. When we look at our lower bound is going to be 125. Our upper bound is going to be 150. And then we get to type in the mean and standard deviation that they give us in the problem. Again, since these are not z-scores, we're not talking about a standard curve, we use the values that they give us. All right, so let me go split screen. I'm going to keep the split screen on after this one so that we have it for the next part. We're going to go second vars, normal CDF. And then type the stuff in there, 125, comma, 150, comma, 110, comma, and 25. Hit an enter. And I find out that 0.2195 or 21.95%. Now again, I'm fine with the 0.2195. The only time you got to put in 21.95 is when you see the percent symbol after the box. Like we see that from time to time on our homework problems. Sometimes they don't have it. That means they want the 4-digit decimal. When they have the percent symbol, they want you to move it 2 places to the right and then put that in there. But you're always taking it out 5 places, rounding to the 4th. And so that is what we're doing, unless they tell you different in that homework assignment to round to the 10th or the 100th or whatever. So there's part A. Now, part B, we can do part B with z-scores and use that z-table. All right, so they're saying, but I'm going to try to show you with the calculator. So Mensa is an elite organization that admits members, people who score in the top 2% on IQ tests. what score on that adult intelligence scale would an individual that's in between the age of 20 to 34 have to earn to qualify for that membership? So we're trying to find that X value. So I'm gonna draw my normal curve. Now it talked about the top 2%. So that would mean, and again, granted, there's technically not that big of a tail there, but your top 2% is what we got to imagine is to the right. If we're using the Z table, what do we have to? Can we use the 2% to help us find the answer like immediately? No, we have to do what? We got to take about 98. You got to do the same thing with this calculator feature I'm getting ready to teach you. We need to think about, okay, what percent is to the left? 98%. And that's technically the area to the left is 0.98. This calculator feature I'm going to show you is all based on doing to the left. Okay? Now, some of the newer versions of the TI-84 platform software may let you do it to the right. So if it gives us that option, we'll do it both ways. But we have it set up to do to the left. Now, they did tell us the mean. We need to make sure we grab the mean from the problem and the standard deviation. We still need those two pieces of information because what I have now written on the screen, those pieces, this is what I need in order to use a feature in the calculator I'm getting ready to show you. The feature in the calculator is what's called invnorm. And it's pronounced inverse norm is what is the way that is pronounced. And so when we do our normal distribution, like the normal CDF feature in the calculator, it's been there as one of the things down below it. Okay, so as we go through, we got to get that pieces of information. We're going to go hit second vars. And if you look at option number 3, option number 3 has that little inverse norm, INV norm. So we're going to press option 3. And again, yours, if you're using a handheld calculator, will have it listed down, area, mu, and then standard deviation. Now, obviously my Calc 84 is a little different screen. On the handheld calculator, does it give you like to the left or to the right or center? Yep, it gives you left, right, and center. Okay, so right now we have it set up for left with this 98%. Okay, so what I want you to do is I want you to put in 0.98, comma, type in the mean, 110, comma, 25. Now again, all you had to do was just arrow down the things. Now make sure it stays left on the last one, then go down to paste. Okay, so 0.98, and if you don't put in 0.98 and you did 98, it's going to give you an error. Okay, you can only put in a decimal less than 1 in that area category in that calculator for this feature. Okay, so now I'm going to hit enter, and it gives us a score of 161.34. So you'd have to score above, scoring above 161.34 makes you eligible for the for that membership, for the membership. Okay.
I have a question.
Yo.
So if you did that question using Z-score, it came out to 161.25. If we're doing a test for the homework or something, and just because I did it with Z-scores instead of the calculator,
I would take either. Okay, I would take either. I usually have it defaulted to do the inverse norm this way, is what I have it defaulted to grade by. But I'd always look at to see, okay, how far are you off, and then I would take both. And then if I when we look at doing a test, probably by Wednesday of next week, we're looking at doing this chapter 2 test. I'll make sure to try to have the Z-score method as well, and do those. For the AP exam, they'll take both and stuff is what they're set up to grade by. They have both answers listed that way, it'll take either one. If it was a multiple choice question, you'd pick the one that's closest to it, is what you basically would do. But if it was a fill in the blank, I'll try to have it set up to do both. The key thing is if you're going to do it, Andy, like yours, if you're going to do it by hand with the Z-score, make sure in any sub-process stuff you keep as many decimals as possible. And then once you get done at the very end, that's when you round. Okay, because that's what I'm going to do, because that's standard what you're supposed to do with math, is you don't round until the last calculation is done. And that's pretty much general with all the textbook stuff and online assignments. That's when it's rounding, is at that last calculation step and stuff. So if some of you have been off some, is it because you're rounding in the first step of doing something and then you keep using that rounded number all the way through? Well, then it's going to be wrong. You got to keep 7 or 8 decimal places through the whole process. Then eventually at the last one, then you round. So we know what the score there. Now I can't, those watching the video, you'd have to look. I don't have the option to do this up on the screen. But for everybody in the classroom, let's go back and do an inverse norm. Okay? So let's go back and do an inverse norm. And with the updated platform of the calculator, it did have the option of left, center, and right. So what I want you to do is for the area, put 0.02. For the mean, put our 110. For our standard deviation, put 25. And I want you to arrow over and choose right. Because what that's telling the calculator is I want to find out, hey, that's 2% to the right is what's here. And once we hit enter, it should give you the same value, does it? Okay, cool. So if you're using my handheld calculators, you don't have to adjust and make it the 98%. You just got to make sure you say shading to the right is what you're doing on those handhelds. If you're using the Calc 84 app, you're going to have to do it like the Z table. You're going to have to make it to the left in order to put it in, because it doesn't give me an option to go in left, right, center. Okay? I've never tried the center feature on there, so you might want to, if you want to try it, this way you guys can help me on this one. Let's do that same thing, and just let's say it's like, I guess 2% is in the middle. So choose the center option. And I'm curious if what it does, if it gives you two answers. And is it separated with a comma?
Yeah.
All right, so it gives us what two answers?
109.373274.
Okay. All right. So that's telling us that, hey, 2% of the score, of the things, if you were in the middle 2%, I guess it was, on that situation, that would be scores from 109 to 110, 0.67. So basically, that would be on our normal curve. If we had our mean was 110, that's saying that's like real close. Not even that. It's like that much. That's that 2% in the middle around the mean is what it's showing here on that one. So I guess it's going from 2% about the mean on either side. So there's the answers for the next one. I don't even know. Do you guys have the options for the answers on the next one? Did I forget to delete them? Or did I?
For 13A, we use like that to find the middle. Well,
No.
I guess not, because
No.
it's not the right
Right.
information. Okay.
Yeah, because they're giving us those bookmark
Okay.
numbers.
But if it gave us between this percent and this percent, would that work?
Probably could. Emma's trying to think. If it said, if they gave me what are the two numbers, because it's going to do it in relation to the mean. So if they said between 30% and 60%, we know that's only 30%, but when you put that in that inverse norm, it's going to go 15% on both sides. is not going to shift. So yeah, so I probably would not use it. Yeah. So yeah, no, good question. Good question. So number 14. Here we have a problem, and as we look at it, they want us to find what percent of the babies will be identified as low birth weight. They tell us that they did 400,000 newborns, 6-year period. Normal distribution, great. Mean is 3668, standard deviation of 511. Babies who weigh less than 200 or 2,500 grams are classified as low birth weight. What percent of babies is that? Okay, so we're trying to find the percent. So this is going to be still a normal CDF. And as we think about it, they tell us, they said below 2,500. So my lower bound is basically 0. My upper bound is 2,500. I know a baby can't weigh 0, but they also can't be negative. So we're just going to put 0 as the very bottom level. Our mean is 3,668, and our standard deviation is 511. All right, so let's get into our normal CDF. Second distribution, normal CDF, 0, 2,500, 3,668, 511. And I get 0.011135. So we're looking at about 1.11%. So 1.11% of babies are classified in this model as low birth weight, is what it is, in that country. The next one, find the first and third quartile. So we want to know, on the next part, we want to know what numbers. Let me see if I can get this thing off of here. I'm obviously on my answer key version, not on my my blank version that I distribute to you guys. Sorry if I try to give us some room. So they want us to figure out the first and third quartile. So I have Q1, I have Q3. I'm trying to figure out what those are, is what I'm trying to figure out. And so, again, I'm trying to find basically an X value that represents these two things. So that lets me know I'm going to use inverse norm. If I'm trying to find a percentage, I'm using normal CDF. If I'm trying to find a value, then I'm going to use that inverse norm if I'm trying to find that X value. Now, you could also do the X value based off of the Z table. You can also do that as well. But since I'm trying to find the value for quartile 1 and quartile 3, what is that X value? I'm going to use the inverse norm to help me out with that process. Okay? I think over the years, as I've taught it, some people haven't made that association. When do I use what when I've introduced both things? Percentage, normal CDF. Physical value, X value, inverse norm. Okay, that's the trigger in our mind. When do I use which feature? And that's the hard part with this course. As you learn more and more techniques in the calculator, they all start get jumbled up. And so it's trying to keep a simple way of keeping track. So again, our mean we said was 3,668. Standard deviation is 511. That's it. That's an easy one to remember here. That was like my first address of the house we lived at in Delaware. 511. So now let's go in and do our inverse norm. Now this is where we got to remember what percent is associated with quartile 1. Yeah, 25%. So quartile 1 is associated with 25% to the left. So that means my area is going to be 0.25. My mean is 3,668. My standard deviation is 511. So we go second, vars, and inverse norm. and then we're gonna type in those things: 0.25, comma 3668, comma 511. Enter. Oh, Mr. Stevens, what the heck did you do? Oh, you know what I did? What do you notice I typed in with my fingers as the very first number? I did 25, not 0.25. I didn't hit the decimal long enough. Again, and that's what I mentioned earlier, is you have to type in a number less than 1 for the area. And because otherwise it gives you an error like this. So second enter. Let's see if I can backtrack. Okay, forget that. I pressed normal CDF, my fat finger. I hit the wrong thing. Okay, let's clear the screen. Second vars inverse norm. Now we go 0.25, comma.
You missed the point again.
Dang it. My fingers, holy smokes. Point. Still not there.
No.
All right. But yeah, broke the decimal point. I worked it too hard. All right, area, vars, inverse norm, area, point. There we go, 2.5. There we go. And then 3668, and then comma, 511. All right, so that tells us that quartile 1 has to be 3323.34.
We're going to the left or the right?
That one's to the left. That's the lower bound. That's quartile 1. Is that less than what our mean is? Yes. So I'm doing quartile 1, which would be 25% to the left. So 3,323 is what that is. Now, when you do the next one, it depends on if you're using the Calc 84 app or if you're using the TI calculator. You could technically say 25 to the right because that is what's to the right of quartile 3. Okay, or you could use 75% or 0.75 if you want to stay with the left. So, and again, you only have that option when you're using the handheld calculator. So on the next one, trying to find quartile 3, if you want to stick with doing to the left, you would go 0.75 and then type in the same information. And then choose to the left is what you want to make sure you do. And that's what I have to do on the Calc 84. You could also do as the area, and this is only on the TI calculator, is do 0.25 and then the 3668, the 511, and then choose it to the right. And it will give us the same answer that I'm going to get here in a moment. So second vars, inverse norm, 0.25, good, it stayed on there, comma 3668, comma 511. Enter. And Mr. Stevens, you doofus. I put 0.25. I should have put 0.75. You guys didn't even, I guess you were concentrating on you typing it in, so you didn't notice my boo-boo. Quartile 3 would be 4,012.66. So I would assume probably they'll probably tell you to round to the nearest whole number. So probably 4,013 if they want you to round to the nearest whole number. And then we probably go 3,323 on that one if they're doing nearest whole number. Now I will say, in some cases in our stats course, we will always round up. All right, we will always round up. Just like with percentiles, we always rounded down to the percent to the left. If even it was 16.9, we would say it was the 16th percentile or whatever, because you had to make sure you didn't have anything to the right of it. If we're doing things and our percentage represents living objects, then sometimes they'll have us round up no matter what. So 17.1 would be 18. All right, as we progress through our course. And Any questions on using that inverse norm feature?